India's growth depends heavily on the energy required to sustain it. With a spend of over 7 lakh crore rupees annually in acquiring oil to fuel its tremendous growth, the strain on India's economy is mammoth. In 2004, a company named Cairn India discovered massive reserves of crude oil in Bardmer, in the barren desert of Thar, Rajasthan. In a terrain where all forms of life seek shade from the scorching sun, thousands of men worked round the clock, eventually striking what they sought: oil. Name Mangala, or the auspicious one. 25 subsequent new discoveries were then made in the same field. Named Mangal, or the auspicious one. 25 subsequent new discoveries were then made in the same field. It has over 4 billion barrels of crude, out of which 1 billion barrels are recoverable. Production from these reserves provides nearly a quarter of India's domestic oil production. It was hailed as the biggest onshore discovery in India in the past 25 years. But for the team of engineers, this discovery also presented a challenge. The oil extracted from this field was waxy in form, solidifying almost as soon as it reached the surface. Thus, maintaining the fluidity of the oil as it made its way to refineries situated many hundred kilometers away was a daunting task. The way forward involved constructing a 700-kilometer-long, continuously heated and insulated pipeline running across Rajasthan and Gujarat, keeping the waxy crude liquid throughout. Nothing of this kind had ever been attempted before. The cutting-edge, revolutionary technology known as Skin Effect Heat Management System, or SEMS, a complex engineering solution designed to maintain the temperature of the crude oil at the optimum level of 65 degrees Celsius. The design involved 2 pipelines over the entire length of the line, one 24 inches in diameter carrying crude and the other 8 inches in diameter carrying natural gas. The system uses heat generated due to electrical resistance, which is then transferred to the crude oil through conduction to achieve the desired temperature and to ultimately ensure it remains fluid throughout. And then began the construction of a true technological marvel, a continuously heated and insulated pipeline, which used state-of-the-art techniques like microtunneling to cut through rocks and lay pipes, negotiating and preserving 700 man-made and natural crossings like canals, rivers, and railways, an achievement that undeniably stands at the pinnacle of pipeline engineering. It is a story of courageous vision